Pluto is a distant and mysterious planet that was formerly a single member of the family of planets in our local planetary group. Leading astronomers Neil deGrasse Tyson and Michio Kaku have made startling claims that have thrust Pluto back into the public eye, claiming that the frigid planet may be headed straight for a collision with Neptune. However, how might this occur? And what may happen in the wake of such a horrific incident? Is this impending massive collision something more than what we are seeing? Or are we just seeing an intriguing cosmic oddity? Come along with us as we explore the potential impact of Pluto and Neptune. Due in large part to its remarkable orbit, Pluto, a former planet that was demoted to a dwarf planet, remains a topic of discussion and investigation among the galactic community. Leading scientists have recently made predictions that show how dangerously close Pluto's orbit is to Neptune's. Tyson and Kaku are warning of the possibility of a violent collision between these two planets that might be extremely dangerous for Earth. But how even is such an event possible? Pluto's orbital period around the Sun is the longest of any planet in our solar system, taking an astounding 248 years to complete. This indicates that it hasn't even made a full revolution since its discovery in 1930. The story doesn't end there. Pluto's orbit deviates sharply from the almost circular paths of the big planets, giving Pluto's route a very elliptical appearance. Pluto's orbit is even more peculiar because of its predicted 17 degrees inclination toward the ecliptic plane. Pluto travels on a route that is far steeper than that of the other planets. Its circular shape and inclination give its orbital pattern additional layers of complexity. The point where Pluto's orbit intersects Neptune's course is among its most intriguing features. In contrast to what one might anticipate given their relative positions in the solar system, Pluto actually approaches the Sun more frequently than Neptune during each of their roughly 20-year orbits. Naturally, this raises the question, why hasn't Pluto collided with Neptune? The gravitational pull of other planets holds the key to the solution. Soon after Pluto was discovered, researchers started looking into its orbit. Initially, unlike the other planets whose orbits are slightly close to the ecliptic plane, astronomers attempted to determine the reason behind its unusual route. The circular shape and high inclination of Pluto's journey made it stand out. When it was discovered that Pluto's orbit truly overlaps Neptune's, the puzzle became much more complex. Pluto's orbit stability in the face of these complications is evidence of the complexity of space mechanics. Determining the motion and gravitational pull of three space objects, such as Pluto, Neptune, and the Sun, is known as the three-body problem. It's like trying to guess where they're going to go by looking at where they begin and how they interact with each other. This problem for Pluto illustrates the intricate interaction between its journey, Neptune's path, and the gravity of the Sun. The phrases VZK oscillation, alpha libration, and scope libration are crucial components of this conundrum. Astrophysicists claim that the alpha libration is responsible for maintaining the orbits of all planets. This phrase, as it relates to Pluto and Neptune, indicates that Pluto is always at least 90 degrees distant from Neptune when it crosses its orbit. It is essential that they be separated spatially to avoid their orbits crossing. Conversely, scope libration describes the vertical motion of a celestial body within its orbit. This means that Pluto is positioned considerably above the orbital plane of every large planet, including Neptune, when it is closest to them, offering an additional layer of protection against possible impacts. The VZK oscillation, which bears the names of three experts who examined how objects move in space, Bond, Zippel, and F, is another important aspect of this scenario. It concerns the gravitational force that three celestial bodies, Pluto, Neptune, and the Sun, have on one another. Their movements are influenced by this pulling. Regarding Pluto, the VZK clarifies why its orbit around the Sun is so peculiar. Pluto's orbit appears chaotic, but this oscillation keeps it traveling in a steady manner for millions of years. The VZK oscillation demonstrates how certain patterns and laws hold everything together in space, even when everything appears chaotic and random. By keeping Pluto's orbit steady, all of these elements prevent it from straying from its intended path or colliding with Neptune. We can better grasp how these components vary according to the forces these space objects exert on each other thanks to this three-body dilemma. We can learn more about Pluto, the solar system, and other far-off worlds and their stars by studying this. In spite of these steady characteristics, Pluto's orbit is actually turbulent, with small variations in initial conditions resulting in large variations over thousands of years, as demonstrated by mathematical simulations conducted in the late 1980s. Nonetheless, it has been shown that these unique characteristics of Pluto's orbit preserve stability over extraordinarily long timescales, controlling the chaos. We now know more about how the giant planets, such as Neptune, Jupiter, and Saturn, affect Pluto's orbit around the Sun according to recent computer models. Neptune and Pluto have a special relationship in which Neptune completes 3 orbits around the Sun for every 2 that Pluto completes. Not only does this link serve to maintain Pluto's trajectory stability, but Jupiter's gravity also contributes significantly to the orbit's protection. Indeed, Pluto will remain on a stable course for billions of years, at least thanks to Jupiter's gravitational pull alone. Apparently, Neptune, Jupiter, and Saturn are coordinating to ensure that Pluto travels through space safely and trouble-free. These quirks are essential to preserving the order and consistency of celestial bodies' motions in the larger scheme of the cosmos. Our solar system would be far more chaotic and unpredictable without these systems. Pluto and other bodies have the potential to collide or be ejected from stable orbits, which could have an impact on other celestial bodies. Knowing Pluto's orbit is crucial, especially in light of recent speculation that it may collide with Neptune. It helps us understand the dynamic nature of the solar system better. Pluto serves as an example of how complicated interactions between orbital mechanics and gravitational forces can bring even the most obviously unstable orbits into balance. It also demonstrates how crucial it is to keep tracking and studying these phenomena in order to comprehend the cosmos and our place within it. Pluto's orbit serves as an excellent illustration of the unpredictable nature of celestial bodies, which is something we frequently encounter while venturing into the deeps of space. Pluto serves as a powerful example of the idea of orbital chaos, which describes the sensitive dependency of a celestial body's journey on its beginning conditions. This implies that the dwarf planet's long-term orbit can be significantly altered by even minute changes in its position or speed. Scientists have found that using virtual simulations has greatly aided in their understanding of Pluto's space travel. These simulations model the gravitational attraction between Pluto and other space objects, such as Neptune, using advanced mathematics. Scientists may observe how even minor modifications can have a significant impact on Pluto's final location by adjusting minute parameters in the simulations. These models showed us something incredibly fascinating about Pluto's orbit in the late 1980s. Its route can be unpredictable and untamed, even with features like scope libration and AFL to keep it stable. Pluto's trajectory can change dramatically over many years if you start with even a small alteration in its location or speed. Pluto's orbit, however, stays constant for billions of years despite all of this devastation. This indicates that although Pluto's orbit around the Sun initially appears chaotic, there is actually some order to it. It is quite difficult to predict infinite events, particularly when they involve chaotic orbits like Pluto's. Because of these systems' intrinsic unpredictability, long-term forecasts are frequently rife with uncertainty. Mathematical models are an effective tool for understanding and forecasting the behavior of celestial bodies in the future, but they also show how limited our ability to forecast is. Precise forecasts are difficult to achieve since these models mainly depend on the complexity of the interactions they simulate and the accuracy of the initial conditions. Even the smallest error or misstatement can have a significant impact on the outcome. Furthermore, the erratic character of celestial orbits, like as Pluto's, serves as a reminder of the universe's constant change and dynamic nature. Even while we've come a long way in our understanding of space, the Pluto case serves as a reminder of how little we actually know about the cosmos. Gaining knowledge of the giant planet's gravitational pull on Pluto's orbit is essential for comprehending the solar system's overall dynamics. It demonstrates how the stability and trajectories of other bodies within the system can be significantly impacted by the presence and location of each planet. So why, in spite of all these intricate mechanisms attempting to avert such an event, are prominent astrophysicists only now voicing concerns about a possible collision between Pluto and Neptune? Astrophysicist Neil deGrasse Tyson, who had a significant role in popularizing cosmology, provides a distinctive viewpoint on the riddles of our solar system, particularly the intriguing case of Pluto. Tyson offers perceptive commentary on the changing nature of celestial physics and the public's obsession with the uncharted territories of space. Tyson is well known for his part in reclassifying Pluto from a planet to a dwarf planet. Tyson's viewpoint regarding the renaming of Pluto is based on our solar system's ever-growing body of knowledge. He sees the name as a necessary modification to our expanding knowledge of the several bodies around our Sun, rather than a devaluation. His method of studying celestial mechanics is one of ongoing adaptation and learning. He believes that there is still a great deal to learn about space due to the complexity of orbits like Pluto's. The curiosity surrounding these issues, especially the potential interactions between Pluto and Neptune, emphasizes how dynamic and frequently unexpected our solar system is. His research highlights that the more we learn about space, the more questions appear, encouraging us to carry out additional research and improve our comprehension of the cosmos. Another well-known physicist and futurist, Michio Kaku, focuses on the frequently surprising forces that shape our cosmos and presents another, although complementary, viewpoint on the mysteries of space. Kaku is a prominent voice in talks concerning celestial physics and its wider implications for humanity because of his reputation for being able to make the connection between cutting-edge visions and difficult scientific topics. In order to anticipate and comprehend possible cosmic occurrences, Kaku's theories regarding Pluto and its orbit emphasize the importance of ongoing observation and sophisticated modeling. He believes that research on the interactions between heavenly bodies is essential for both intellectual and practical reasons. For instance, the possible collision between Pluto and Neptune serves as a reminder of how dynamic and frequently chaotic space is. Kaku's futurist viewpoint exhorts us to think about the wider ramifications of such occurrences, ranging from how they may affect our comprehension of the solar system to whether further space interventions may be necessary. Kaku's perspective emphasizes how crucial it is to be ready for anything unforeseen when traveling in space. His research indicates that our ability to navigate and possibly lessen the effects of cosmic occurrences will increase with our understanding of the forces at action. The ideas that space is a field of limitless discovery and that our present understanding, however extensive, is yet restricted are shared by Tyson and Kaku. Their focus on the necessity of ongoing research and sophisticated modeling is indicative of how space science is developing. They emphasize how crucial it is to comprehend celestial mechanics not just as it exists today, but also to make predictions about how it might evolve in the future. The possible collision between Pluto and Neptune offers a case study for the more general difficulties and possibilities associated with space travel. It emphasizes the necessity of cutting-edge technology, thorough scientific investigation, and a readiness to modify our theories in light of new data. According to Tyson and Kaku, the mysteries of space, such as Pluto's orbit, should inspire the scientific community and all of mankind to continue exploring the limits of our understanding. The orbits of Pluto and Neptune are thought to remain stable for a very long time because of their mean motion resonance and the different gravitational forces operating on them, according to the agreement of scientists. It is therefore extremely unlikely that Pluto and Neptune will collide directly. To have a better understanding of these celestial bodies' long-term behavior and any possible hazards, astronomers must continue to observe and study them due to the intricacies and potential perturbations in orbital elements. Even while it is still highly speculative and implausible given what we know now, the prospect of a Pluto-Neptune impact emphasizes the value of continued research and observation in space science. Technological developments, like as better telescopes and computer simulations, will aid astronomers in honing their models and forecasts, enabling us to remain aware of the dynamic and always evolving nature of our solar system. Tyson's take on Pluto's renaming and Kaku's focus on the unpredictability of celestial mechanics both emphasize the importance of ongoing research and a flexible knowledge of the cosmos. Even though the hypothetical crash scenario shows the intricate and dynamic connections inside our solar system, it ultimately serves as a reminder of the enormous amounts of space that we still do not fully understand. We work to solve these puzzles via continued investigation and observation, making sure that our understanding keeps up with the universe's constant advancement.